of y equals x squared plus 3 and y equals x squared minus 5. Y prime equals 2x. It doesn't matter whether the constant was 3 or negative 5, but I don't know why that's in there, so we'll just cross it and go negative 5. Oh, you don't have that. Okay. Since when we take the derivative, the constant disappears. However, when we try to reverse the operation, we find the antiderivative of 2x. What do we get? Y equals x squared plus c. We don't know what the constant is, so we put plus c, don't forget the c, right, in the answer to remind us that there might have been a constant. So if we have more information, we can actually find the c. So this is the first step of this section, is we are going to actually solve for the c. So first example, given y prime equals 2x and y equals 4 when x equals 1, find the equation for y. So find the antiderivative of this, we get y equals x squared plus c. So can you figure out how you're going to find the c? Yeah, you set y to 4 and x to 1, and you go. 4 equals 1 squared plus c. So what does c equal? So then what's my actual y equation? Y equals x squared plus 3 as my final answer. Pretty easy. This is called an initial value problem. We need the initial values to find the constant. An equation containing a derivative is called a differential equation. So once you guys are done in university, Calc 1, Calc 2, actually it's Calc 1A and Calc 1B, or is it Calc 1, Calc 2, and then the Calc 3. Then after that, you get into differential equations. It's another course. Like if you go into engineering, you're going to be taking so many calculus courses. It'll be differential equations 1, differential equations 2, and it'll keep on going like that. Okay, it becomes an initial value problem when you are given the initial conditions. Make sense? And we are asked to find the original equation. Find the particular solution to the equation dy dx equals e to the power x minus 6x squared whose graph passes through the point 1, 0. So it's very similar. So dy dx is just a fancy name for y prime, right? So what's the antiderivative of e to the power x? E to the power x, the derivative is itself. And what's the antiderivative of minus 6x squared? So add 1 to that, you get x to the power 3, and then you divide that, you get minus 2, and then don't forget the c, right? Okay, so now we got to use the information 1, 0 and plug her in. So I'll give you a second to do that and find what c is. So if I put 0 in for y equals e to the power 1 minus 2 plus c, yes? So if I get c equals minus e plus 2, that's an e. So therefore y equals e to the power x minus 2x to the power 3 minus e plus 2. Everybody get that? Yeah? Okay, so those are pretty straightforward, nice and easy, right? Okay, now we're going to get into initial value problems, and differential equations can be illustrated with what's called a slope field, or sometimes called a directional field. Okay, so we're going to construct a slope field for the differential equation y prime equals 2x with initial condition 1, negative 2. So you're supposed to sketch the curve. If you understand this, this is probably one of the easiest things on the exam. So all you have to know is, you know, essentially when you're plotting the y prime, you're plotting a line that represents the slope. So a slope of a half is like this, and the slope of 2 is like this, and the slope of 4 is like, you know what I mean? So it's just a rough thing. They're not going to measure your little lines or anything like that. So anyways, the first thing we should do is actually plot 1, -2 on here. So 1, -2 is right there. Yes? That means that the graph actually goes through there. Okay, so and they will not provide you with this table. So I provided you with this table, and eventually you'll have to come up with your own table. So anyways.
Yeah, I don't know where you got the 1 from.
Oh, right here.
Oh, there, okay.
Yeah.
The table, I'm like, I don't know where it is.
Okay, so now we're going to be plugging this in. 0 goes in for x there, and what do we get y prime to be? 0. So this is how it works. At the coordinate 0, -2, we're going to draw a little tick that represents a slope of 0. Okay, so at 0, -2, which is right there, a slope of 0 is like that. Okay, so actually, if you can see, it's not going to change for any of the ones that are x is 0. They're all going to be 0 for the slope, right? Does everybody agree? I'm subbing that into here, and I'm going to get 0 for the slope. So that means at 0, 2, 0, 1, 0, 0, it's all going to be this horizontal line. Okay? So far so good? It's kind of weird at first. It's weird too. I know when I took calculus in university, we never did SlopeFields, so it's not until I actually taught the AP course that we actually did this. It's kind of practical, I guess, but I don't see the real thing to it. But anyways, so when 1 goes into here, we get a slope of 2. So for both 1s, it's a slope of 2. So at 1, 0, so 1, 0 is right here, you need a slope of 2. So just think of the 45-degree line as a slope of 1, so then it has to be a little bit more, right? Like again, it's not anything, do you know what I'm saying? Slope of 1 is a 45-degree angle, so slope of 2 is a little bit steeper, yeah? And then at 1, 1, it would be the same thing. Like that. Okay, at -1, 0, so -1 goes in there, we get a slope of -2 this time. So at -1, 0, again, we have the 45, so then it's a little bit steeper. Okay? So does everybody see at all where x is 1, you're going to have a slope of 2. So you can start filling this in pretty fast. Like, so this is this, yes? And then this would be all this, yes? When x is the same, because we're only using x in our differential equation, all the slopes that have the same x will be the same. Make sense? Kind of like here, all the slopes were 0, all the slopes were +2, all the slopes were -2. So let's do when x is -2. What's our slope? -4. So -2 would be -4. So that's really steep, right? Super steep. And I can do it on the other side, a +4, right? Super steep. Okay, so now you got to imagine what function is happening here. Can everybody picture this as an x squared graph, which makes sense. Y prime is 2x. We know it's going to be an x squared graph. We don't know what the plus c is, right? We could actually solve it by subbing it in. I'm sorry? It's -3. But you can see, if it goes through here, do you see it has to be going like this? Yeah? So again, all I'd have to do with this to figure out what it was is if y prime equals 2x, y equals x squared plus c, sub that in, you get -2 equals 1 plus c, c equals -3. So I know this was y equals x squared minus 3. You're not going to get easy ones like this where you can actually solve it. You're supposed to be able to look at this and kind of get a picture of what's happening here. Okay? Like for instance, the next example, you probably don't know what that would be as the antiderivative, right? Okay. Are we good here? Okay, so sketch the graph of the solution of the initial value problem. So y prime is equal to x plus y, and y of 0 is 1. So we're going to plot 0, 1. It has to go through there. That's my initial. We got it? All right. So, oh, yeah.
For the first example that we gave, what's the point of it to find what the equation would have been?
Actually, a lot of the times, like for instance, you'll say match the differential with the slope field, or draw a slope field. If you look at the AP exams, they might start off as draw a slope field, use the initial conditions to find the actual solve the actual differential. Like that's how the different parts are. Does that make sense to you? So this might be an A question. This might be a B question. So now we can actually get into longer responses. You know what I mean? So, which then you have that to look forward for this test one. Okay. So again, this table is not provided. You can do it if you want. You can probably do this in your head. It can go that fast, right? So if I wanted to start, for instance, at 0, 0, my y prime now has to do with both x and y. Do you see that? So x and y add up to 0. So it's a slope of 0 there. If I wanted, say, 0, negative 1, what's my slope this time? Negative 1, right? So that means at 0, negative 1, it's a 45 going like that. If I want to know at there, but do you need to put it down as a table? You probably know what the answer is now. All you're doing is adding them up, right? This would be negative 2, which would be a steeper like that, right? What about up here at 0, 1? I'll actually write 0, 1 down. What's the slope there? 1. So there's a slope of 1. At 0, 2, it would be a slope of 2. So far, so good? Okay. So let's do, say, 1, 0. You see 1, 0, the slope would be 1. So that would be a 45 right there. And really anything that adds up to 1, you'll have that 45, right? So again, at some point, you're not going to use this table. You're just going to do it in your head, right? So 1, 1. Does everybody see 1, 1? That'd be a slope of 2, so that's a steeper one. Oops, that's pretty steep. Again, they're not going to take a ruler and measure how steep it is. You're just supposed to get a general. They're kind of just looking, where's the slope 0s, where's the slopes 1s, where are they really steep, etc. 1 and 3 make 4, it's really steep. Here, this is 2, 2, 0, so that would be a slope of 2, so that's steeper. 2, 1, that would be even more steeper. This is even more steeper. Can you see what's going to happen here? No, not yet. How about this one? This is 1, negative 1. That's a slope of 0. Can you see it's kind of going like this? Yeah. Yeah, there's probably going to be an asymptote in a second. Is there anything that makes it undefined, though? That's undefined slope, because that's where you'd have the asymptote. No. Okay, so what about here? 1, negative 2 would be a negative 1 slope. So that's like that, right? And actually, if you start thinking about it, anything that's in this diagonal will be a negative 1 slope. Like this one, negative 1. This was 2, 1. Do you see? This will be a negative 1. This will be negative 1. Do you see how easy you can start filling this in? Was there any other ones here that was a positive one? Positive 1? No, there's nothing there. How about here? 3 would be steep. 3, 1 would be steeper. Steeper. This is 3, negative 1. So that's negative 2. So like, sorry, positive 2. I said that wrong, didn't I? 2, negative 1 would be negative 1, right? Sorry, would be 1. 1. 2, negative 2. Sorry, 1, 2, 1, 2. That's a 0. You see, this would be a 0, 2 then, right? And this would be a 0. You see how this is all working? So then let's start filling. What would this one? This is 3, -3. Oh, that would be another 1, 2, 3, 1, 2. No, so this is a 2. So this is 3, -2. So this is a slope of 1. There's my slope of 1's going up here. This should be a slope of 1, hey? Yeah. Yeah? So then on this side, we have what? -2, 0. So this is a slope of -2. This is -1, -1. So this is a -2. This is -3. So that's a slope of -2. -3, this would be even more steeper, right? This is -3, so this is even more steeper. And this is even more steeper. Okay, so I'm going to use a different color kind of pen here. What do you think looks like here? Yeah, like one of those. It has to go through here, right? And so something like this. Yeah? Like right here is a slope of 0, right? You have to make sure it's just.
How is there so many zeros? Is that just if it's shifted to multiple?
Yes, because the plus C we don't know. So if it's shifted up, that would be like that curve. If it's shifted down, good questions. Remember, we don't know what the plus C is until we solve it, right? So we know, because we have this initial value, we know it has to go through here, so it has to be that part, right? Yeah.
Do you have to draw a line on every point given on the graph?
Yeah, you're supposed to. Well, actually, I should look that up because it might say, this I actually took straight from an exam, I think. So that maybe you do have to do as many, but it goes fast, right? Like once you start going, you can see where the pattern's going, right? Okay, let's see if we can do this multiple choice. Actually, it's not a multiple choice, it's a match. And if we have time, we're going to do a match later too. So.
3 and 4 are the same.
Okay, they're not. Okay, so how do we figure this out?
I'm going to say 1 is B.
Okay, so we got to use this logically. The slopes of zeros are probably the easiest thing to pick out. Does everybody see? We have a slope of 0 going right here. So for instance, 0, 1. 0, 1, 0, 2, 0, 3, 0, 4. So we know that A cannot be 4, right?
I'd say A is 3 because whenever X is from 0, Y, like that was that whole thing.
Okay, so let's just do a couple of other things. We can totally narrow this down. So.
But see, the problem with 2 is that if Y was 0, then that also means that it would be.
Yeah, when Y is there, which is everything here, that means it would be a horizontal line. So we know that A is not 2. So we're deducing that it must be 3. So let's pick another one. Let's figure out positive and negative, right? So if I take, say, when X is 4 and Y is 4, that's about a slope of 1. How about when X is 4 and Y is -4? That's a -1. Let's go over here and do negative, negative. Yeah, so I'm thinking this is 3. Or we can put A here if you want.
Yep.
C has to be 2 then, so let's see.
It's always like when X is 0,
What-
Y is
When X is 0, we have a horizontal. When Y is 0, what do we have there?
to be. It's because it's both zeros. Or wait, never mind.
Have to be 4
Do that before.
because there's no slope of 0 when
There's an asymptote.
Yeah, does everybody see that they don't indicate a slope here, which means it has to be undefined. So do you see 4 has to be C? Yes? Does that make sense to you? Okay, so then what else now? These all have slopes of zeros here.
B is probably A because of the graph. The graph we just did is kind of like the opposite.
B is A, you're,
Alright, B is 1. Sorry.
B is 2?
And C is 1.
B is 1.
Yeah. That's
Okay, so let's just see.
kind of the opposite of the one we just did, which was X plus Y.
Yeah, well, you won't have that. So let's use logic of how this stuff is here. So, for instance, when x is 0 and y is 1, it's a negative slope. This looks good and promising for sure. This one, it definitely doesn't work. So by elimination, for sure. So this is 1, and this is 2. This is D. And this is B, yes?
So do we, instead of saying to write a reason, do we have to write a reason or
No, we kind of just, give reasons. We kind of said it out loud, but maybe you could write it down. But it has more to do with, here is an asymptote, of course, right? This has, you can see where the zero slopes are, things like that. Does everybody see how you'd match them? I have a good matching game later, if we have time. Actually, this was taken from an AP exam. So this is how many, this is actually an AP question. So there you go. So it says, consider the differential equation dy dx equals negative 2x over y. On the axis provided, sketch a slope field with 12 points indicated. So they're saying you need to have all 12 points to get the marks. No. Are you kidding me? It's like 1 mark. Oh, they're a little bit lenient that way. They kind of look at this and see, do you have the general? If you miss 1, they're not going to, yeah. But I wouldn't take any chances, though. Anyways, so where do we know we have a 0 slope? On the x-axis. Y is 0 is right here. You can't have y 0. So this would be undefined here. But I'm saying here, when x is 0, we're going to have a 0 slope all there. Do you see that?
So if you're indicating that's fine, you can put the asymptote there.
I'm sorry? You don't put anything there then. No. So the question was, how do you indicate an asymptote? Don't put anything there. Right? So I guess that would answer your question. If you miss one out, that implies that there's an asymptote there. Okay, how about, what about 1, 1, 0? That would be undefined. This whole thing is undefined, so we have to leave this whole thing blank. Does everybody see that? So this is going to be so negative 2. So like that. This would be 1, 2. So this would be negative 1, right?
Okay.
Negative 1. And again, all they're looking for is, do you have the tick in the right slope, positive, negative, and kind of half looking.
Bigger than the other.
Kind of, yeah. So 1, negative 1. So this is 1, negative 1. So this would be a positive slope, right? So that would be a positive 2. And then 1, negative 2 will give you a positive 1 slope like that. Yes? And then over here, if we have negative 1, negative 1, that would give you a negative slope, right? So negative 2 slope.
It's just kind of
And negative 1, positive 1, that would be, yeah, it looks like it's all a nice reflection. Yeah. You got it all right? So what does that look like then?
Is it a circle?
Kind of looks like a circle, but the whole problem is if it's a circle, it shouldn't be going through there, right? So guess what? They give you some initial conditions here. It says let y equals f of x be a particular solution to the differential equation with initial condition f of 1 equals negative 1. Write an equation of the tangent line of the graph 1, negative 1, and use it to approximate f of 1.1. Do you remember this from before? Yeah, it's all coming back now.
Or is it like a secant or cosecant graph? And then like
Okay, well, let's just relax here. Let's figure it out, right? Okay, so what are we going to do here? What are we going to do here? We have 1, negative 1. So what's the slope at 1, negative 1? 1, negative 1. 1, negative 1. So what is it? 2. Do you know how to write a slope of a tangent line? So y minus minus 1 equals 2x minus 1. So you can actually leave it just like that, right? If you probably should, because it's way easier to find f of 1.1 that way, right? So 1.1, it goes in there and then it's easier to find, right? So y plus 1 equals 2, 1.1 minus 1. So 1.1 minus 1 is 0.1. I'm just going to go over here. So y plus 1 equals 2 times 0.1. So y equals 0.2 minus 1. So y equals negative 0.8. Therefore, f of 1.1 is negative 0.8. Everybody good with that? Find the particular solution of y equals f of x to the given differential with the initial condition f of 1 equals negative 1. Okay, so this is getting crazy now. So we have to start with dy dx. dy dx equals negative 2x over y. Okay, so this is their first kind of introduction to differential equation solving it. So what we're going to do is we're going to do a cross multiply across so that we get y dy equals negative 2x dx. Okay? Then what I'm going to do is I'm going to impose an integral to both sides. So what is the integral of y with respect to y? It's the same thing, but it's with respect to y here. So add 1, you get y squared, and then divide by that, so you get 1/2. Yes? Or multiply reciprocal. Equals, what is the antiderivative of there? And actually, I need a plus c. Nobody said anything. Plus c equals, on this side, what is the antiderivative of minus 2x? Negative x squared plus c. Now, here's the thing. It's a different c. So I'm going to put c1 and c2 because it is technically a different c. So now I'm going to solve for y squared. And here's the, I don't know, I'm just going to go 1/2 y squared equals negative x squared plus c2 minus c1. Now, if you think about this for a second, once we start solving this, although they're different, we can, and this will blow your mind because it's kind of like, what? We can actually just make this into c. No, well, we don't even have to call it c3. It's just a new constant. We're calling it c. So we get 1/2 y squared equals negative x squared plus c. But you're supposed to designate them between the two and then kind of combine, like get them whatever. So then we get y squared equals negative 2x squared plus 2c. But do you see if I put plus a 2c, this is going to blow your mind too. If I put a plus 2c, it's still a constant, so it's just still c. Are you okay with that? Because the first time you see that, you're kind of like, what? How can you do that? It's not a variable, right? It's just some constant we're going to figure out later. Okay, so now we need to use the initial value in there. 1, negative 1. So we need to put 1, negative 1 in, right? That's what it was, 1, negative 1? Yeah. So 1 goes in for x, negative 1 goes in for y. We get 1 equals negative 2 plus c. So what does c equal? 3. So what's my equation? Y squared equals negative 2x squared plus 3. And you might say, well, so if you solve for y, do you remember how to solve for y? How do you solve for y? Square root both sides. So you get y equals plus or minus the square root of negative 2x squared plus 3. Okay, so now here's the thing. Once you solve for it, it has to work for your initial conditions. So at this point, we might be rejecting one of these. You know what I'm saying? So we need to check 1, negative 1 and see if it works. So just do by pure inspection. Let's check. Y equals the positive negative 2x squared plus 3. Does it work there? And y equals negative square root negative 2x squared plus 3. Check in both. Do they both work? And you should probably know by now that how do you get a negative equal to a square root, right? So so this one would be rejected. Do you see that? This is the only one that does work. Yes? Look, if you put 1 in, you get 1 squared. Negative 2 times 1 is negative 2. Plus 3 is 1. So in both, you're going to get the square root of 1. But the y has to equal negative 1. And the only way you'll get negative 1, you can't get a square root of negative. Like, there's no negative here to make it negative 1. This is the only one that would make it negative. So this is my equation of my differential, not the plus or minus. So say you forgot about plus or minus, and you just left it as a square root, you'd actually get it wrong, because it's actually the negative one. Do you see what I'm saying? So not only do you have to remember when you square root is plus or minus, you also have to check to see that you have that. So there's a SlopeField worksheet